So just as a reminder, as we move on to three variables in Math 098, Chapter 4, Section 2, we are still solving, which means finding a value for the variable, in this case, variables, to make the equation true. So again, that's just sort of highlight for you what we're looking for when we do this. Now, we're doing three variables. A little known fact in math is that if you have three variables, then you better have three equations. So what does that mean? Well, if we're talking about linear, what we're talking about are planes, because it's three-dimensional. Now, we usually draw, we can solve by graphing. I'm just not going to ask you to because it's very, 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 very difficult. We're going to do a combination of elimination and substitution. But let me explain to you what's happening is, I hope you remember from geometry that a plane is a flat surface. There's no depth to it. We usually draw them using parallelograms. But if you just think about the top of your desk, you know, the floor, the ceiling, the walls, those are all examples of planes. So what's happening is if we have planes that intersect, so here's one plane, I'm going to make another plane that looks like it's going straight up and down. Got to use your imagination for a second. So two planes, if you remember from geometry, intersect at a line. So there's a line, just think of two pieces of paper that cross each other. And that's why we need three planes, because I'm going to make a third plane. Let me just change colors to try and where it's going sideways. So where the three planes are going to intersect then, like they intersect right here, is right here in the middle. Now if you open your book to page 279, they draw a much better visual for this than what I just drew. But if you think about like a corner of a box, if you just purchase something from Amazon, you got the bottom of the box, you got the side of the box, and then you got the back of the box. They all intersect at a single point. So, like, I'm trying to draw a box in here that we cut open, and you don't see these two sides, or the top, I guess. You can think about the ceiling, and two walls, or the floor and two walls, I guess is what I just drew right there. But they also do a really good job in your textbook of showing you a visual on why it's more or I guess I should say it's easier to have no solution. Because just like lines can be parallel, you can have planes that are parallel. Just think about if you have a two-story house, you know, the floor of one and the ceiling of the other, and then the floor of the next and the ceiling of the other, they never intersect each other. But you can also have visuals where maybe two of them are parallel, and then, you know, I don't know, you have like a straight up and down. Just think of this picture as like the floor, the ceiling, and the third one is the front wall. They do not intersect at one point. And you can also have a visual where several of them they all intersect each other, but they never intersect. So there's a third plane on this side, which you can't really see now. That they don't intersect at one point. So here's several pictures. They're all on page 279. But then there's also a visual on page 280 on why you could have infinitely many. So page 280 is the infinitely many. And if this is going beyond your, if you're not quite understanding these visuals, it's not a big deal. You won't be asked this on a test, but it might help you understand why we teach it. Infinitely many, just like a line, two-dimensional, the lines can fall on top of each other. You can have planes that are exactly the same. So imagine the floor being on top of the floor, which is on top of the floor. That would be infinitely many. But you can also have infinitely many where they're not the same. And again, page 280 has a good visual for you where maybe you have a plane that crosses a plane at a line right here. But then there's another plane that also crosses at that same exact line. So infinitely many solutions, but none of them are the same. So worth the read if you have the time. Otherwise, we're going to move on to solving a system. Now, when I do this, I usually stick with elimination. And that's the way I'm going to teach it. Is what I tell my students is to find a variable that is easy to manipulate. So I would say all of these are pretty easy, but there is an easiest one, and that would be these z's. Because as I'm looking at the z's, all I have to do is multiply this top equation by 2, this middle equation by 2, and I don't have to change this bottom equation at all to be this. Now, what you also have to notice is 1 must be the opposite of the other 2. Opposite of the other 2. What do I mean by that? Is it doesn't matter if one's plus and the other 2 are minus, like in this situation, or if one's minus and the other 2 are plus. You just need one of them to be the opposite, and that's going to be the key to finishing this problem. So if I look in that numerator, I'm so used to the numerator being the top, but I'm going to distribute that 2 to everything in the top. And I put a little dash my z so it doesn't look like a 2 equals negative 30. The middle equation is going to be 2x plus 4y minus 2z is equal to 2. And that bottom equation is going to be the same because I don't need to change the z's. Equals 0. So now that I'm looking at this, the one that is the opposite is the one that I'm going to use twice. And the reason why I'm going to do that twice is I'm going to eliminate the variables by putting the opposite one and combine it with the other 2. And maybe I'll color code this. So by combining the 2z with this 2z, you'll get 0z. And that's why you don't want to do the 2 that are the same, because negative 2z plus negative 2z is is negative 4z. But they don't cancel. That's the whole point. So in the top 2 equations, I get 8x plus 2y. I hope you see where I'm doing. 6 plus 2 is 8. Negative 2 plus 4 is 2. The z's cancel. That's a 0, by the way. Negative 30 plus 2 is negative 28. Like I said, I should color code this. So I'll do the top and the bottom now. That's too close in colors. In this blue color. So 6 plus 2 is 8. Negative 2 plus 3 is 1. The z's cancel like I want. Negative 30 plus 0 is negative 30. Now we're down to 2 variables with 2 equations. If you have 2 equations, you need 2 variables to solve it. Or if you have 2 variables, you need 2 equations to solve it. So what I'm doing is I'm just negating the second equation. That way I can cancel out my x's here. 2y plus negative 1y is 1y. Negative 28 plus 30 is 2. But you're not done. I don't know what I just said because I had to erase what I just did because I put y equals 2 into the wrong equation. I don't know why I did it that way. And you can do either of these 2 equations, just make sure you put 2 in for the y, and that's where I went wrong earlier. But I fixed it. So subtract 2 over, so we're at negative 32, and when you divide by 8, you get x is negative 4. And now you're going backwards. Notice that you go to your equation. When you have one answer, you go to your equation with 2 variables. Now that we have 2 answers, we go to our equations with 3. You can do any of these 6 equations. I'm just going to go back to the one that had a positive z. So 3 times negative 4, and I'll change colors again. I get negative 12. And then y is 2 is equal to negative 15. So that's negative 14 that I can add to the other side. Negative 15 plus 14 is negative 1. So our answer is an ordered triple, just for the record. And if you want to write it as an ordered triple, you can, where you write the x coordinate first, then the y coordinate, and then the z coordinate. go. So I'll just quickly do the next one. If you want my opinion, I would probably look at the x's being the same. That just popped out at me right away. You don't have to do it that way, but I only have to multiply this bottom equation by 3 to get that -6 plus 3y, and then minus 12z would equal 9. So now when I'm looking at my x's and the terms that match up, the terms that cancel, I'm looking at positive, negative, negative. So which one's the opposite is the one that's on top. So if I try to combine them, I need to combine the top with the middle. So that's going to be y, because the x's cancel, 1y plus 10z is equal to 4 plus 7 is 11. And then combine that top one with the bottom equation. So the x's cancel, the y's cancel, the z's cancel. Oh, it's 0 equals 4 and 9. That would be 13. Oh, that's a false statement. And so what that means is the top and the bottom were parallel to each other. Like if you look at your visuals, they're parallel to each other. So is there any way that this middle line could be created in here to even create a solution? No. I shouldn't have called it a line, the middle plane, but it is no solution. So we can stop right there. Once you get a false statement, it's impossible for them to join together. So again, pause these videos, as I'm sure I'm going fast over this, but I'm assuming you learned some of this in Algebra 2. I think I'm actually going to stop here and create a new video.